Good morning, sir. So today, I will be presenting my research project in physics, which is the comparing which supersaturated solution will refract light the most. Introduction. Background of this study. Supersaturation is the driving force for crystallization and is a requirement before a solid phase will appear in a saturated solution. Early studies of the phenomenon were conducted with the sodium sulfate, also known as the Glauber salt, because unusually the solubility of the salt in water may decrease with increasing temperature. Because of this, scientists gained control of crystallization processes by carefully controlling the prevailing level of supersaturation during the process. Glauber salt is a kind of salt that is a decahydrate form of sodium sulfate. It is also known as mirabilite. According to physics classroom, refraction occurs as light passes across the boundary between two media. Refraction is merely one of the several possible boundary behaviors by which a light wave could behave when it encounters a new medium or an obstacle in its path, or just a transparent object. The transmission of light across a boundary between two media is accompanied by a change in both the speed and wavelength of the wave. Problem statement. Comparing which supersaturated solution will have the highest degree of refraction. Objectives. Comparing which supersaturated solution will have the highest degree of refraction, salt, sugar, and MSG. This experiment aims to know which one of the supersaturated solution will refract light coming from the laser pointer the most. The other is that to know why does the light refract on the supersaturated solution. Part 2, Scientific Background. Refraction. In an article from Science Learning Hub 2012, refraction is a kind of phenomenon wherein the light bends when it passes from one transparent object or substance to another. It means that the light that passes through a transparent object is the refracted light. Supersaturated solution. According to Lumen Learning, supersaturated solution is a kind of solution that contains more than the maximum amount of the solute that is capable of being dissolved at a given temperature. It means that when the solute dissolves in the solvent at the high temperature and when the temperature drops down, or when it returns to room temperature, that solution will become a supersaturated solution. Part 3, Methodology. Variables. Dependent variable. Refraction of light. Independent. Three different supersaturated solution. Controlled variable. Volume of water. Temperature. Brightness of the light. The duration of solute to dissolve in the solvent, and the location of the light. Materials. 3 containers, laser pointer, salt, sugar, MSG, protractor, water, wall, gas burner, and pot. Methodology. Phase 1, Preparation. Number 1. Plan how to execute the experiment. Identify the materials needed. Gather the materials needed. The researcher should first prepare the 3 containers to be pre-washed in water and dishwashing liquid and submerged in bleach solution. After 3 minutes, the containers should be left to dry in the sun. While preparing the containers, the water will be put in the pot and will use the gas burner to boil the water inside the pot. It will be preheated up to boiling point. Then the researcher will put 3 different materials, salt, sugar, and MSG, into the 3 different pots. Then the researcher will keep stirring to dissolve the material, and it will be repeated until the solution becomes a supersaturated solution. Methodology. Phase 2, Experimentation. After the supersaturated solution is ready, The researcher will put the container beside a cardboard, a plywood, or on a side of the wall. The researcher will point the laser one at a time in the three containers filled with three different supersaturated solution. When the laser pointer is gotten on the other side of the container and in the wall, the researcher will check if there's any refraction of light on the other side of the container. The researcher will use a protractor to measure the refraction of light in the other side of the container. After the researcher measures the refraction of light, the researcher will record it as degrees in the table. Results: supersaturated solution, salt, sugar, MSG, degrees of refraction. The degrees of the refraction of the salt. When pointed at 130 degrees, the degrees of the refracted light will be at 60.5 degrees. Degrees of refraction of the sugar is the light is scattered so that it is hard to determine what is the degrees of the refraction. Degrees of the refraction of the MSG. When pointed at 130 degrees, the degrees of the refracted light will be at 55 degrees. Part 5. Conclusion. According to the result of the experiment, the salt supersaturated solution has a 60.5 degrees of refraction, while MSG has a 55 degrees of refraction, and lastly, the sugar solution cannot determine the degrees of refraction. Looking at the results, we could conclude that the MSG supersaturated solution will refract light the most. Recommendation. The researcher recommend the following for further research. Use the same sizes of containers. I prefer the containers that the sides are parallel to each other. I forgot to put out this one, but the other one is that they should use materials that will produce transparent object when it crystallizes at room temperature. References. These are the references. Questions. What is your dependent variable, independent variable, and controlled variables? My independent variable is the refraction of light. Dependent variable is the refraction of light. Controlled variables is the volume of water, temperature, brightness of light, the duration of solute to dissolve in the solvent, and the location of the light. Why the light refract when it passes through the supersaturated solution? The light refract because of the transparent object in the supersaturated solution. But in this case, I think that the light refract when the light passes through the containers itself. What improvements would you recommend for researchers who would want to conduct a follow-up study to yours? I recommend that they should use same sizes of the containers so that the results will be valid, and they should use materials that will produce transparent objects when they make it into a supersaturated solution. Why the sugar supersaturated solution did not have any result? I think that it did not produce any result because of the there's too many crystallization in the container or transparent object in the container. Because of that, the light just bounces to each other, resulting that kind of result. Is the experiment valid and reliable? I think that the experiment is not valid and reliable because first of all, the three containers are not of the same sizes, and lastly that the light only refract because of the and light only refracts because of the containers that were the supersaturated solution were in. That's all, sir. Thank you for listening.